grade 7. For today, I will discuss with you about the properties on the operation of integers and converting fractions to decimals and vice versa. And this was based on Mathematics 7, Quarter 1, Module number 4.
This is from LRMDS Bulacan. Thank you and congratulations to the development team of this module. Credit to the author, language reviewer, content editor, illustrator, and layout artist of this module.
Hi math lovers! Are you ready? Let's learn! Have fun! Because mathematics is fun!
What I need to know.
This module provides varied activities that will help you to learn about the different properties of integers, fractions, and decimals. At the end of this module, you are expected to first, illustrate the different properties of the operation of integers. Number 2, express rational numbers and fraction to decimals form and vice versa. And number 3, appreciate the important properties of integers, fractions, and decimals in our daily lives.
What I know. Now turn your module to pages 3 and 4. Let's answer our pretest. Read and understand its question. Choose the letter of the correct answer. What's in? Turn your module to page 4. Find the 10 hidden words that make up the properties of the operation on integers and kinds of rational numbers.
Hi! I provided these jumbled words for you, and this was based on the word pun earlier. Now, can you guess these jumbled letters? Correct! That is closure or closure property. Now, try this number 2. Correct! Associative or associative property. Word number 3. Correct! Distributive or distributive property. Word number 4. Correct! Inverse or inverse property. Jumbled word number 5. Correct? Commutative or commutative property. Jumbled word number 6. Correct. Identity or identity property. For number 7. Correct. That is fraction. Number 8. Correct. That is decimal. Number 9. Yes, integers. Lastly, number 10. Yes, that's zero or zero property. Correct.
Now, let's try to review our answer. Let's give the words that we found. The first word is associative, distributive, inverse, commutative, identity, fraction, decimal, integers, closure, and we have zero. That is the 10 hidden words. What's new? Now turn your module to page 5. Try to reflect on this. Give at least 5 words or synonymous or related to the word A. Property, B. Convert. I will give you the 10 words. Particularity, possessor, change, alter, attribute, ownership, remake, revise, modify, and holder. Using these 10 words, give the synonyms of property and convert. Let's use the box below. Particularity. Where we will place particularity? Yes, related to property. Next is change. Related to convert. Ownership. Yes, related to property. How about revise? Yes, to convert. How about possessor? Yes, it's for property. And for alter, this is for convert. How about modify? Yes, for convert. How about attribute? That is related to property. The word holder is also related to property. And lastly, for remake, that is related to convert. This is our 10 words. What is it? Lesson number 1. Properties of operations on integers.
Properties of operation on integers. Number 1. Closure property. Two integers that are added and multiplied remain as integers. The set of integers is closed under addition and multiplication.
Now let's have example number 1. And this is for addition. 6 plus 3. These two numbers are integers. This is equal to 9, which is also an integer. Negative 8 plus 9. These two numbers are also integer, and their sum is 1. Example number 2. For multiplication. 5 times 7 is equals to 35. 5, 7, and 35 are all integers. 7 times 5 is equals also to 35. 7, 5, and 35 are all integers.
The second property is commutative property. Changing the orders of two numbers that are either being added or multiplied does not change the value.
Let's have example number 1. And this is for addition. 5 plus 4 is also equal to 4 plus 5. Even the addends change their position, their sum is the same. 9 is equals to 9. For example number 2, this is for multiplication. We have 3 times 9. And this is also equal to 9 times 3. Even the factors change its position, Their product remains the same, which is 27.
Property number 3. Associative property. Changing the grouping of numbers that are either being added or multiplied does not change its value.
Example number 1. For addition, the sum of 3 and 7 plus 5. 3 and 7 are enclosed in the parentheses. It is also equal to 3 plus the sum of 7 and 5. Now let's answer 3 plus 7. That is equals to 10, and then bring down 5. Now let's try 7 plus 5. That is equals to 12, then bring down 3. Their sum are both equal to 15. Let's proceed to example number 2. And this is for multiplication. The product of 3 and 7 times 5. 3 and 7 are in group. This is also equal to 3 times the product of 7 and 5. Let's try to answer 3 times 7 and bring down 5. Let's try 7 times 5, then bring down 3. Their products are the same, which is 105.
Property number 4. Distributive property. When two numbers have been added or subtracted and then multiplied by a factor, the result will be the same when each number is multiplied by the factors and the products are then added and subtracted.
Example number 1. And this is for addition. The sum of 5 and 6 multiplied by 4. First, multiply 4 by 5. The product is 20. Now 4 times 6. That is equal to 24. The sum will be 44. Let's proceed to example number 2. This is for subtraction. Difference of 8 and 3 multiplied by 5. 5 times 8 equals 40. 5 times negative 3 equals negative 15. Their difference is 25.
Property number 5. Identity property. For additive property, it states that the sum of a number and 0 is the given number. 0 is the additive identity. And for the multiplicative identity, it states that the product of any number and 1 is the given number. Or A is equals to 1 and 1 is equals to A. And 1 is the multiplicative identity.
Let's have different examples. This is for addition. 8 plus 0 equals 8. 0 plus 100 equals 100. And for 12 plus 0, the sum is 12. These examples is for multiplication. 5 times 1. The product is 5. Now we have 1 times negative 6. The product is also negative 6. 89 times 1. Yes, the answer is 89.
Property number 6. Inverse property. In addition, it states that the sum of any number and its additive inverse is 0. The additive inverse of a number A is negative A. In multiplication, it states that the product of any number and its multiplicative inverse or reciprocal is 1. The multiplicative inverse of the number A is 1 over 8.
Let's have these examples. This is for addition. We have here 4 plus its additive inverse, which is negative 4. What is our sum? It is equal 0. Then we have negative 100 added by its additive inverse 100. The sum is 0. For number 2, we have to add its additive inverse, which is negative 2. The sum is 0. Now let's try these examples. And this is for multiplication. 8 multiplied by its multiplicative inverse, which is 1 over 8. What is our product? The answer is 1. Now, let's try this one. 1/4 multiplied by its multiplicative inverse, which is 4. Our product is 1. Our next given is 2 multiplied by its multiplicative inverse, which is 1 over 2, is equals to, yes, 1. Lesson number 2.1. Rational numbers changing decimals into fractions.
Rational number. A rational number is a number which can be written as a quotient of two integers where the divisor is not a zero. The word rational comes from the word ratio, which means quotient. Thus, any number that can be written in fraction form is a rational number. This includes integers, terminating decimals, repeating decimals, as well as fraction. Or we have different forms of rational numbers. The first one is the integer. An integer can be written as a fraction simply by giving it a denominator of 1. So an integer is a rational number. Since whole numbers are natural numbers and subset of integer, thus they can be a rational number.
Now let's try these different examples. We have 6. Change this in the fraction, we have 6 over 1. Now we have number 4. Changing this to fraction, we have 4 over 1. Then we have negative 2. Changing it to fraction, we have negative 2 over 1. Lastly, we have 25. Changing into fraction, we have 25 over 1. Just remember, we did not change the value of each number. 6 and 6 over 1 are equal, while 4 is equals to 4 over 1. Even negative 2 is equals to negative 2 over 1. Of course, 25 is equals to 25 over 1.
Number 2. Terminating decimal. A terminating decimal can be written as a fraction simply by writing it the way you say it. 3.75 reads as 3 and 75 hundredths. In fraction form, it is equal to mixed fraction, 3 and 75 over 100, also equal to 375 over 100. And the lowest term is 15 over 4. So, any terminating decimal is a rational number.
Now look at these examples. 1.25 reads as 1 and 25 hundredths. And in fractional form, it is 1 and 25 over 100, 125 over 100, and 5 over 4. Let's have our next example. 2.5 reads as 2 and 5 tenths. In fractional form, we have 2 and 5 over 10, 25 over 10, or 5 over 2.
Number 3. Repeating decimal. it can be written as a fraction using algebraic methods. So any repeating decimal is a rational number.
Let's have example number 1. We have here 0.333 and 3 dots, meaning number 3 is repeated. And this is equal to 3 over 9. Logically, the repeated digit is 3 and the decimal place nearest to it is tens. Subtract 10 by 1, so it becomes 9. Thus, 0.333 and 3 dots is equal to 3 over 9. Now, let's proceed to example number 2. We have 0.25, and 3 dots, meaning 25 is repeated. This is equals to 25 over 99. The repeated digit is 25, and the decimal place nearest to it is hundreds. Subtract it by 1, so it becomes 25 over 99. Let's proceed to example number 3. We have 1.121, then 3 dots, meaning 121 is the repeated number. This is also equals to 1120 over 999. The repeated digit is 121, and the decimal place nearest to it is thousands. Subtract it by 1, so it becomes 121 over 999. 1 and 121 over 999. Add this to whole number 1, it becomes 1120 over 999. 1 times 999 is equals to 999 plus 121 is equals to 1120. This is the square root of 2. Is this rational or not? The square root of 2 cannot be written as a simple fraction, and there are many more such numbers, and because they are not rational, they are called irrational numbers. All fractions are rational numbers except with 0 denominator. Example, 5 over 8. All terminating decimals are rational numbers. Example, 0.4. All repeating non-terminating decimals are rational numbers. Example, 2.737373 and 3 dots, meaning 73 is the repeated number. Lesson number 2.2, Rational Numbers, Changing Fractions into Decimals.
That we have learned how to convert decimal into fraction, now we'll try to express fraction into decimal form. We have two methods. The first one is the long method division, and the second one is giving its similar fraction. Using the first method, which is the long method division, we have 3 steps. Step number 1, use the numerator as the dividend and the denominator as the divisor. Step 2, apply the methods in dividing numbers, such as divide, multiply, subtract, bring down. Step 3, if the dividend is less than the divisor, you may add 0 after the decimal point. Example, 5 is equals to 5.0 and it is equals to 5.00 and also 5.000. The value doesn't change.
Using the first method, we will use long method division. Let's have example number 1. 5 over 8. we will use 5 as the dividend. And number 8 will be our divisor. Then, let's divide. 5 divided by 8 is equals to 0. 0 multiplied by 8 is equals to 0. Third step, subtract. 5 minus 0 is equals to, yes, 5. Now, we will add additional 0. Put a decimal point after 5 and on the quotient. Then, you may add 0. You can now bring down 0. Proceed again to step number 1, which is division. 50 divided by 8 is equals to, yes, we have 6. 6 multiplied by 8 is equals to 48. 50 minus 48 is equals to, yes, 2. Again, we will add 0. And then we have to bring it down. 20 divided by 8 is equals to, yes, we have 2. Then 2 multiplied by 8, the answer is 16. 20 minus 16, we have 4. And again, we will add 0. Then, bring it down. 40 divided by 8, we have 5. 5 times 8, we have 40. 40 minus 40, we have 0. Therefore, 5 over 8 is equals to 0.625 thousandths. Again, using the first method, which is the long method division, let's have example number 2. We have 7 over 11. We use 7 as our dividend and 11 as our divisor. Let's divide. 7 divided by 11 is equals to 0. 0 times 11 is equals to 0. Now let's subtract 0 from 7. 7 minus 0 is equals to 7. Now, we need to add decimal point at the end of the dividend and in our quotient. Then, let's add 0. Bring down 0. 70 divided by 11 is equals to 6. 6 times 11 is 66. 70 minus 66, we have, yes, we have 4. Again, we will add 0 and bring it down. 40 divided by 11, we have 3. 3 times 11 is 33. Subtract it from 40, we have 7. Again, we will add 0 and bring it down. 70 divided by 11 is 6. 6 times 11 is 66. Subtract it from 70, we have 4. Now, what have you noticed? Negative 66, negative 66, then 40, and 4 or 40. There is a repetition. So you have to add 3 dots, meaning 6 and 3 repeating decimals.
Using the second method, which is giving similar fraction, you may use this another method with these 3 simple steps. The first one is find a number you can multiply by the bottom of the fraction, so make it 10 or 100 or 1000 or any one followed by zeros. For step 2, multiply both top and bottom by that number. And for step 3, then write down just the top number, putting the decimal point in the correct spot, one space from the right side for every zero bottom number.
Let's have example number 1. Convert 3 over 4 to decimal. We have 3 over 4. Step 1. We choose 25 as multiplier to make the divisor 100. 3 over 4 multiply by 25 over 25. Step 2. We can multiply 25 by both numerator and denominator so that the denominator will become 100. 4 times 25 is equals to 100. 3 times 25 is equals to 75. Step 3. Write down 75 with the decimal point 2 places from the right because 100 has 2 zeros. We put decimal point at the right of 75. Move it 1, 2 times to the left. Our final answer is 0.75. Now let's have example number 2. Convert 3 over 16 to decimal. We have here 3 over 16. Step 1. We choose 625 as a multiplier to make the divisor 10,000. 3 over 16 multiplied by 625 over 625. Step number 2. We can multiply 625 by both numerator and denominator so that the denominator will become 10,000. 16 multiplied by 625 is equal to 10,000. 3 multiplied by 625 is equals to 1,875. For step 3, write down 1,875 with the decimal point 4 spaces from the right because 10,000 has 4 zeros. Let's move the decimal places. 1, 2, 3, 4. We have 0.1875 10,000.
Now, are you ready to answer your module? Good luck!
What's more? Dependent activity number 1. Label each fruit as rational if the number on it is a rational number and not rational if it is not. Independent assessment number 1. Turn your module to page 11. Fill in the boxes to convert the following decimal numbers into fraction in simplest form. Independent activity number 2. Turn your module to page 12. Compare the following using the symbol less than, greater than, or equal. Independent assessment number 2. Turn your module to page 12. Express the following into decimal. Independent activity number 3. Turn your module to page 12. Fill in the blanks. Write the missing term according to the property applied to each number. Independent assessment number 3. Turn your module to page 13. Determine the property applied and shade each part of the flower with a color of the property that corresponds to your answer. What I have learned. What I have learned. Turn your module to page 14. Complete the sentence with a personal thought, feeling, idea, or realization based on the topic, properties of operation on integers, and converting fraction to decimal and vice versa. What I can do. For what I can do, turn your module to page 14. Solve the following problems. Assessment. For assessment, turn your module to page 14 and 15. Try to answer our pretest. Choose the best answer. Write the letter of the correct answer. Additional activity. For additional activity, turn your module to pages 15 and 16. For letter A, identify the properties. For letter B, write each decimal as a fraction in simplest form. For letter C, convert each fraction to decimal. References.
watching!